Kubernetes 1.26 new alpha feature, validating admission policy. If I go to the Kubernetes blog, which is electrifying, 1.26 introducing validating admission policies. So this validating admission policy is one of the admission controller. So let's try to understand what is admission controller, how it works in Kubernetes. Let's say you have a Kubernetes deployment. Of course, you have connected the Kubernetes cluster by using one of the kube-config file, and you try to apply this particular deployment YAML. First, internally, this kube API server will check the authentication, whether this guy is a legitimate or not. Then after that, authorization phase, whether this guy having access rights to and all. Then after that, admission controllers. These admission controllers are a part of a kube API server, which will trigger, which will intercept this particular request. Means the whatever this is a request, this request will be taken, read by these guys, and this will apply the internal admission controller. And then if it is all good, then it will proceed further to store in a etcd and so on. This is how typically admission controller will work in Kubernetes. Now, if you look at the built-in and dynamic admission controllers, there are many. Among image policy webhook, mutating admission webhook, validating admission webhook, these are the webhooks we know already, and in the CKS these all are covered, right? But this is a newly added validating admission policy. So let's try to understand first what is this validating admission policy webhook, and then we'll come here. Now, validating webhook admission controller. So webhook, this is just remember webhook, and this is a policy. So this webhook point of view, same, you have a deployment and you have tried to apply, and which is indirectly this is a post request, right? And this will go and hit the kube API server. Kube API server will have authentication and authorization phase, AA. After that, what happens is this kube API server will trigger this validating admission controller, and this validating admission controller will read this particular webhook configuration, and this webhook configuration will have a backend service as well. Means this is webhook configuration. Where is the webhook? This is the webhook. And once this admission controller know where is the webhook, then this will call the webhook, and then yes, whenever something is hit this particular API server, this will trigger this guy will read this configuration, and then accordingly call this webhook, and accordingly whether should accept this request or throw the error. If it is all good, go and store it into the etcd. If not, it will throw back the error to the deployment that this deployment has some problem, some validation message. This is how typically a validating webhook controller will work. Now, here three things. One is backend, which is actual backend. It can be anything, internal or external. Second is this configuration. Third one is a controller. These are the three components. Now, validating webhook, again, how you implement this earlier, right? If it is a Kubernetes cluster, first you deploy a logic service, which is nothing but a webhook, which is this guy, right? Then second, create a validating webhook configuration. Yes, of course, you have to create a configuration. Then enable in the kube API server. You need to go inside the kube API server and enable it. If you are using a managed server, they will enable by default, right? Or else there will be some option to enable. Then test. So this is how we will be using typically by using a webhook, and kube API server level we need to enable this kind of a configuration. You need to go and modify. These are the steps for webhook. Now, validating admission policy. This is today's actual topic. So how it works, how the architecture is. As per the validating admission policy, there will be two different files, which is one is a policy, second is a policy binding. So these are the two different YAMLs we will go through in the next slide. What we will be doing is, in order to create this particular validating admission policy, first we will apply these two, policy and policy binding, in a Kube API server, and that Kube API server will trigger this particular validating admission policy, which is integrated with the Kube API server. Then validating admission policy will be created with a CEL. So means whenever you create this validating admission policy, this will have a common expression language. So why we need to use a common expression language? This is for the validating. So, and the second one is a binding. So you will be creating a binding as well. Means validating admission policy means a policy and as well as a policy binding. These two things. So whenever you apply, then that's it. This validating admission policy will either ignore or it will fail. If it is all good, then it will store in a etcd. If it is anything a failure condition, then it will fail to the respective deployment. So here 1 and 2, and there is another third one is a parameters, which is an optional. If you wanted to use a parameter, you can use parameter. So here overall validating admission policy will have two different things, which is a policy and a policy binding. Policy is by using a CEL, and the most important is this is an alpha feature. So admission registration.kith.io v1 alpha 1 is the actual API. Now validating admission policy. So this is one of the simple YAML, and this example is taken from the Kubernetes documentation, which is which is this particular documentation, right? So here the kind is admission policy, and of course the API is v1 alpha 1 since it's a alpha feature. Once it is done, then you will be giving a name, of course, as usual. So first important is a failure policy. Whenever this validates, whether it should fail or whether it should ignore. Fail means hard failure, it won't let you. Ignore means just ignore. And here match constraint. This validation you wanted to apply on a what? Apply on a deployment resource, on a create and update, on a version 1 deployment API, and API group is this one. So this is the match constraint, and the most important is a validation expression. Here you are giving a validation in the form of an expression, which is nothing but common expression language, which is a CEL. So here you will be just giving in the form of an expression, that's it. No need to implement a webhook or anything. Just this YAML itself will have all the whatever the validation logic. Here what it's saying, object.spec.replicas less than or equal to 5 means these deployment replicas are less than or equal to 5. If it is more than a 5, then if you set a policy as a fail, then it will fail. This is a policy. Now second is a policy binding. This is a policy binding. Policy binding point of view, as usual you will give a name, but here policy name you have to link the whatever the policy you given, this policy you have to specify here. And match resources. Here resource, what is a type of resource? Here resource specific binding policy. Like I wanted to apply this particular policy when environment equal to test. That's a match condition. So this is a typically validating admission policy will have a two different YAML. That's it. And most important is this expression, we need to give it in the form of a CEL. Maybe you may be wondering what is the CEL. We'll see in the next slide. Next, validating admission policy also we can create by using a parameter, right? Again same, validating admission policy, you will give a some name, and failure policy I set it as a fail, hard break. And here validation, what you are giving, object.spec.replicas less than or equal to 5 in the previous, but in case of parameter, params.maxReplicas. What is this params.maxReplicas? Here you have to specify on the same route after the spec. Parameter kind, what is a parameter? Parameter is this is a API, this is a kind of replica limit. So this is a replica limit. Okay, just remember this name. Then next is policy binding. Of course, policy and policy binding. Policy binding point of view, you will give a policy name here, right? That's what the linking should be done compulsory. Second, here you are telling the parameter. Then what is a parameter? This is a param ref, replica limit test example something. So this example I have taken from here. Okay, this is example. So need not to worry where I have taken the example. This is example here, right? When you scroll this particular page, you will be able to see. So this is a name, new name I have given in the blue color, right? Now this is a replica limit. If you carefully observe, this replica limit should be same as this parameter kind. Means in the policy you will specify the expression with the parameter I want. What is the type of parameter, which is a replica limit, and here simply binding place you will just link it only. Always just remember blindly that policy is the actual policy, binding is a linking, and here environment is a test. Then only this will apply all this thing, right? So 1 2 3 is a parameter. If you don't want to use a parameter, just simply give the 5 or 2 or whatever the number, right? And most important is a common expression language is this support. Doesn't works like whatever your own favorite query, this doesn't work. Now yeah, so this name, right, replica limit, that name should be matching with this name. So policy name should be linking in the policy binding, and parameter kind should be here replica limit 1, and here you replica limit 2 doesn't work. Here whatever you specify the kind, this should be the same kind, right? So and this name should be matching this one. Now validating admission policy. Let's say you have trying to deploy a one deployment, right, which is matching this criteria, and you, let's consider you applied this particular admission policy and policy binding. Now when you try to deploy a one deployment, it's a post request, of course, right? Post means it's a updating, submitting, right? Then it will go and hit the Kube server. After A and A, it will trigger validating admission policy inbuilt in a 1.26 as an alpha feature. This policy will evaluate with a common language expression whatever you specify. Then after that binding also, and if you specify param also, which will matches and evaluates, and which will tells the whether ignore or fail. If your policy is setting as a ignore, means it will go and store it into the database, that which is etcd. If it is a failure case, then it will throw back an error deployment that this is the what the error. And the good thing is in the validating admission policy you can specify the message as well. So if you look at the here, right, validating admission policy, after this expression you can specify the message as well, error message. So if I go to the my documentation, right, here after validation I specified the message as well. So that we will see in the demo. And here 1 2 3, these are the three major components. Now common expression language. So in the previous slide we have seen the common expression language in the 3-4 times. So common expression language is a declarative based. So these are the examples are given, expression and purpose. So first of all, why this common expression language? So is this common expression language is a declarative. So what exactly declarative means? This is my sample. Here the expression, the same example which I taken from the documentation, right? Spec dot object dot replicas less than or equal to 3, I put this expression. So this is a common expression language, right? And this is a declarative. And second is a developer friendly. How it's a developer friendly, this declarative? See here, match consent resource role is a deployment, right? So if I go to the my Kubernetes, this is a Kubernetes 2 node Kubernetes cluster which is I have provisioned by using a Vagrant. Say if I say kubectl explain deployment dot spec, right? Here if I press enter, right, so here what is my object? Deployment is an object, spec dot replicas, deployment dot spec dot replicas. This is an integer value. So here, as per the common expression language, everything is an object. See here, object dot map, object dot envar. So everything is an object. So here a developer, if a developer wanted to put some condition, basically validating condition on the deployment object, I should know easily. I can find out by using what is the path of it. Say if I wanted to put the condition on this, yes, I can put object dot spec dot this, object dot spec dot this. Say I wanted to deploy my deployment on a specific node only, something like that. So you can put the, this is the word, the developer friendly, because developer will know about this particular path, right? Deployment dot spec dot replicas, right? See here, deployment spec dot replicas, right? This is the word, the my path. So this is a, and there is a, other than object, there is a old object, request, and parameters. Object is this current object. Old object is a, whenever you are modifying a deployment, right, and you wanted to know the old value. Let's say I wanted to put an expression, my old value is a 2, you cannot increase to 2 to 5. That kind of a validation if I want, yes, you can put, right? Here developer friendly, it's saying and this is a or condition, this is a not equal to, this is a regular expression, matches condition. So these all are the developers will know, right? Starts with, ends with, dot all, right? So these all are the developer specific. So that's why this is called a common expression language, is purely for the developer friendly. So if I wanted to put my old deployment number is 2, you cannot jump to 5, must be 3 or something. So something like that, you can put a multiple condition by using this common expression language. And you go to the documentation, which is validating admission policy, and completely scroll down. Yes, here, just bear with me a sec. Object, old object, request, yes. So this validating admission policy is itself is an admission controller, one of the. So admission controller will work on an entire request, right? And parameters, as we have seen in the parameters in the previous slide, that where you can pass a params file. So these are the 4 about the CEL, right? And in the CEL you can use a namespace and escaping characters by using this kind of double dash, double underscore, right? And the documentation is given, what is the purpose and all, right? You can go and explore. And there is a GitHub page as well, so where they given a logical operator, macros, etc, etc, etc. So this is the CEL spec dot doc. This is what the MD file, right? And let's go back to the slide. Now we have seen validating admission policy, these are today's topic, and validating admission webhook, which is initial slides. So what's the difference, right? And if I go to the my documentation, admission controllers, and completely scroll down, validating admission webhook, admission policy, both are under umbrella of admission controllers, right? So what's the difference? Admission policy is for the in process, and this is for the custom logic. How exactly? Validating admission policy is in process, means this is a validating admission policy. This expression you are putting on a where in process, this deployment has this path, nobody else, right? So means this validating admission policy, you can put it on the only on the in process only, right? So here minimum replica, maximum replicas, or everything, whatever is available in Kube API resources, right? Say Kube API resources, right? So this Kube API resources only you can put the condition on this particular Kube API resources. That's what it's saying. Second is this a CL based, yes, this is a CL based, and other one is incoming request. Of course, this is purely works on an entire incoming request. And webhook is definitely a webhook. You have to host a webhook which will take care of actual logic, but here you are using an in process specific. and this is also on the incoming request. So this is a very high level. I hope you understand what is this webhook and policy, right? It's a simple name itself, and these words you should remember. That's it. Now the demo time. So demo point of view, Kubernetes cluster, one master and one worker node. So this is my cluster, one master and one worker node, which is running on a 1.26.1, which is a very latest, and container runtime is 1.6.15, which is very latest, and this is a Ubuntu main. And I have provisioned by using this Kubernetes cluster by using a vagrant. These all are the steps. If anyone interested, please go and try. This will install 1.26 and latest container runtime as well. Now, so this validating admission policy is how to install and how to configure. First, since it's alpha feature, we need to enable in the master node, and second is, since it's alpha feature, enable the its alpha feature API also in a master node. So these two can be done by using a hyphen feature gates validating admission policy equal to true, and as well as hyphen runtime config admission registration.k8s.io. This is the one. So these are specific to alpha. Once it is moved to the beta or general feature, these two you need not to enable, it will automatically. So for now we are in alpha, so how to do, right? For that I need to go inside the master node and update this feature gates. So this is the my work. This is my master node, and I will navigate to the etc, right, Kubernetes manifest, right, and ls. So this is my kube API server and vi, and this is my kube API server, and under the command, so we need to be a little bit careful while doing this, right? So here hyphen, so it's there already given feature gates equal to, so hyphen feature gates, it's a plural, right, equals to validating admission policy equal to true. So let's go to the documentation, right, and just copy this word, right, I don't want to type, and is equal to true, small t, right, and this is enabling the feature alpha feature, and the second is API. This is the API, right? So if you go to the our YAML files, this is the API, and in fact go to the documentation, right? So this is the API. So this API also we should tell the our kube API server that we need this API also. So what I will do is hyphen, right, runtime config. So hyphen runtime config. So we need to be a little bit careful, and this one equal to true. That's what the we have to make it, and save and close it, right? And then it will take a minute to up, and now go back here and just enter the kubectl get node. It will take a bit of time. I will pause the video. Now my node is up and running. Say kubectl get pod and kube system namespace. Yes, my kube API server master is running, and if I wanted to kubectl describe pod and the kube API server pod, right, runtime config, yes, this is done, and feature gets it done, right? So this two-step process is completed. Now the third, create a validating admission policy, right, that we have seen in the documentation. So this is a creating validating admission policy, and this entire example I have taken from here. So this is example, but instead of 5 I just made it as a 3, and there is a message which is not there here, and I have added a message. That's it. This is the what the policy as it is, and this policy is talking about the deployments star and operations, all the operations, not only create and update, but I want to do on all v1 apps, right? And this is the policy, and policy binding, right, and go back here, policy binding, this is also same YAML file. This is a policy binding, same, right, and policy name is this, and this policy name I am referring here, match resources environment in value equal to test. So wherever I'm going to create the environment, that environment should have a label of this test, right? So this is the what the, so yeah, I will just go and deploy this. So now clear. So kubectl apply -f and the demo one. So it's installed admission policy and policy bind, and let's verify. kubectl get validating admission policy, yes it exists, and kubectl get admission policy binding, yes policy binding are exist, and you can just verify as well. Policy binding I'm checking, this is the what the policy binding, right? And if I wanted to check only just a policy, and it starts with the demo. This is the what the policy, and it specified everything, what are the my deployment star and all, right? What is my condition and all. So now if I go back and look, my binding is saying match resources namespace selector, namespace should have a label environment equal to test. So I have a kubectl get namespace, I have a default namespace, so I wanted to test in a default, right? So and namespace I wanted to see along with the label, this hyphen label, right? Default namespace doesn't have any label, so I wanted to make a label as a environment equal to test. So that is again ckad we have learned. So kubectl label namespace environment equal to test, right? Now the namespace is labeled with the environment equal to test. Perfect. Now everything is ready. So now how do we test? So this is rule is on the deployment, so we have to create a deployment. So kubectl get deployment. First let's see, is there any deployment? Nothing is running, right? And kubectl create deployment web, and which is nginx and replica. What's the condition? Our condition is should list less than or equal to 3. I'll try to specify 5. See, I got an error failed to create a deployment apps, web is forbidden, validating admission policy something and denied. All deployment should have at least 3 replicas. This is the what the message, all deployment should have a, so let's change this, should have a mandatory replicas. I'll just make it as a mandatory with yeah, this is the mandatory. Let's see, right? And I will go again here. So here just now I applied, right? kubectl apply, I'll reapply here, and this is unchanged, this only one reconfigured. I will try to create the, and by the way, the deployment is not yet created because it's a validated and blocked as per the our diagram, right? So now I will try to create the deployment. kubectl create again failed, and my deployment, my error message is improved with the mandatory. So this is a demo 1, and the demo 2, which is a parameter, right? In the as per the in the documentation, and we have seen in the slide. So first, so for the again the for parameter point of view, I have taken a the example is from here. This is the what, right? Replica binding, replica limit, and this replica limit, and this is the what the parameter resource. So admission policy, I will go here, and I'm in a demo 2, right? First is, this is as it is I put, and all deployment should have a minimum 3 replica. I put the this 3 number here, and operation just keep it as a star here, same like here, right? So no problem, you can put whatever update, or you wanted to put a delete, just star. And binding also here I taken as it is, I copy pasted here, nothing new here, nothing fancy, right? And as well as, right, so go back documentation, and also they are saying a replica limit, right? So if I copy this, I'll go here, and by the way I have to delete this, right? So kubectl, yeah, nothing. So kubectl delete -f, the demo 1 I'm completely deleted, just voiced out, and I wanted to install. So kubectl apply -f, oops, sorry, my bad typo. kubectl apply -f, instead of demo 1 I'll give demo 2. So here what happened is, validating admission policy is created, and error I got, resource mapping not found for the name. This one namespace is blank for this is the demo 2. No matches for the kind replica limit in the version rules.example./v1. So let's go here. Right here, parameter kind I have given a rules dot and replica limit kind I have given. Ensure CRDs are installed first and then it's created this one, right? So now kubectl get validating admission policy. Let's check whether it's created or not. Yes, only it's created. And validate admission policy binding, right? Also binding is also created, but here error with ensure CRDs are installed first means this kind equal to replica limit is Kubernetes not able to understand what is this kind. So if you go here, kubectl API resources and right here kind, this is a kind, right? Kind equal to replica limit is doesn't have. So means we need to create this replica limit with matching this particular condition logic, etc. For CRD creation, I have created one video 1 year back in my channel. So if anybody did not watch, please go and watch this, how to create a CRD and all. So in that I have given an example of greeting is a CRD. So we will take a reference of the same CRD and we will try to create a new CRD. So I have a CRD here, right? Here what is the CRD? We have to create a replica limit is a CRD name, right? And what's the name here? Already we have given rules.example.com, right? So how the CRD and by the way these annotations and all not required, so I'll just try to remove, I'll just try to keep it simplified, right? Here the greeting is the actual resource. So rules dot and instead of greetings I will just give the replica limits, okay? Replica limit, replica limit, replica limits and replica limit. I will just give that, and replica limit I will give this, right? And API is v1, so we need to give it as a v1 and served storage, etc, etc. And this is only talking about the maximum replicas, but in my CRD not we are talking about the minimum 1 and maximum 10 in that my example, but here maximum replica and there is no condition in the actual CRD, right? So that's it. And email to greeting is not required, message also not there, right? And object open API v3 schema, yeah, that's it. No, yeah, group is wrong, so this is the group I have to give, and the name, yeah. So let me reapply the CRD again. Perfect, it's created. kubectl get CRD, I will see replica limits dot rule dot example is there, and kubectl describe CRD, right? And this one, right? Now it's there. So now cool, now Kubernetes system is able to understand. Now I go back to this demo 2 and here the replica limit maximum limit equal to so it is there. Now if I copy here again and I will reapply the same thing, and here demo2.yaml. So here there is an error, max replica unknown field is saying, means whatever the CRD we created that is not able to detect this max replicas. So just try to understand here, max replica is at the root of this particular replica limit specification, right? But if you go to our CRD under properties, there is a spec, under that max replica is there. So means this CRD is expecting under the spec, which is not there. So what we will do is, the easiest way is we will remove the spec, right? So properties type object, right? And this is also not required, right? So I'll just try to correct it. So basically our CRD is designing, this is the what the spec we are designing, right? So now OpenAPI v3 schema, under that max replicas, it is there, perfect. And we will try to replace this CRD creation again. Just one second. Okay, kubectl apply -f CRD, it's replaced, reconfigured, and let's try to apply this demo to now it's created, right? Perfect. So now kubectl get CRD, this is the what the CRD, right? And kubectl get this one, then this is the what the it's available. And in our demo 2, what is the error message? All deployment should have at least 3 replicas, right? So now I'll try to create a deployment. kubectl create a deployment and 5 replicas. Yes, this is the what the error. So this is proved that the whatever the configuration which is coming from the replica limit custom resource definition as a this particular value, whereas in the demo 1 you are hard coded as a here in the policy itself, whereas in the demo 2 you have created a params and that param as a CRD. That CRD we are created from our previous example. That's it for this particular session point of view. I hope you learned something new. Thank you for watching this video, and please subscribe, like, comment and share. Thank you. Bye bye.